Thank you. Awesome. So I figured that I would do some extra stuff because it seems that there's a lot of people, or half of people here, who aren't really familiar with Azure as such. So I hope that the experts in the room will forgive me for maybe drawing some introductory stuff, because if I dive straight into Azure Functions Premium, then if somebody doesn't know what's Azure Function Consumption or serverless in general, then it doesn't make much sense. So I took this prop here if I need to draw something, because drawing is the best. Let me have some pens here. Let's see. Maybe I don't have to draw anything. It can happen. But I wish I get to draw something. All right, let's see. Where's the old show here? Stopping that. Cool. Still working. Azure Functions Premium. First off, I'm Sakari. I've been coding on .NET since 2001, professionally. Or, yeah, trying to be professional, maybe. I'm a co-host of this Ikkuna Studio podcast. Unfortunately, that's in Finnish, but we have an episode every 3 weeks. I'm the founder of Finland Azure User Group some years back. And then our biggest event in Finland Azure User Group is IgluConf. That's in English, so please join us. It's at the end of January, usually. And then I'm the founder and CEO of this company here, Azure. The co-founder, our CTO co-founded this with me. Azure is a company with 35 people, starting next week, 32 experts. The average experience of people is 14 years. We only do Azure and only platform as a service. So if you guys have some VM issues or infrastructure as a service issues, you can come and ask me, but I probably don't know the answer. So I'm not really very good with that stuff. Our customer satisfaction last month was 4.5 out of 5. There are 4 Azure MVPs in Finland, and our company has 3 of those. And in Great Place to Work, we were 6th last year. So premium plan features. Why would you go Azure Functions Premium? And then the rest is demo. Most of the set today will be demo. I'll try to compare the consumption plan and premium plan inside Azure Functions. And this is, for most of this or half of this room, this is interesting because premium plans are something that just came out. So, and it's in public preview, meaning that it's not really supported by Microsoft yet. So not many of us have used it in production. I hope that none of us have used it in production, but we haven't. But it's interesting to know what are the new tools. But before we go into premium plan features, it would be nice to know how many of you are familiar with Azure Function, or let's put it the other way, how many of you are not familiar with Azure Functions? Excellent. So let's talk about Azure Functions, I guess. So this is now we are in uncharted territory. But Azure Functions, how many of you are not familiar with serverless? What does serverless mean? Okay. So basically, first about serverless. Serverless doesn't mean that there are no servers. There's always hardware. It just means that in the cloud, usually when you compute something, you do some kind of payload, some kind of processing, you choose the size of host. How big is the computer you are running on? How powerful is the processor and stuff? And in serverless world, you don't choose this host. You don't pay for it all the time. Instead, you push your payload, your computational need somewhere, and there is some logic somewhere that runs it, and once it's done, then it's done and it doesn't cost you anymore. So serverless basically means that you pay for it while it's running, and otherwise you don't. And Azure Functions are the Microsoft Azure's one of their serverless products, and I would say that it's one of the key products. There are some others like Logic Apps are serverless and so forth, but Azure Functions are these small pieces of runtime that if you code something on your laptop, that's your laptop, and you code something with Java or .NET or PHP or something, you can push that code into this Azure function, and then this Azure function is something that if it gets, for example, an HTTP request, it gets it, and then it runs your code once. You have your looping and stuff there. It does whatever. Maybe it stores the answer result to the database, or maybe it sends that into some kind of message queue like service bus or event queue or something, and once it's done that, then it kind of dies. So it's a small container, a small code package that lives for just long enough to implement your code. So that is an Azure function, and that is what serverless in this instance means. And Azure functions in Azure traditionally are under so-called consumption plan, meaning that when there's one Azure function running with code inside it or some implementation going on, it might be triggered, scheduled as well. So it could be run every hour or something, so it can be started not just by HB triggers but some other means as well. But when it's running, it's consuming. And consumption plan means that, whenever you run it, it costs you something, some pennies, some cents, and then when it's done, it's done. So that's consumption. And now today, we are going to talk about premium, which is a more robust, more fixed price offering where you actually choose the host. So then is it still serverless? I don't know. We can talk about that as well. But it's a more robust offering of an Azure function. Otherwise, it's pretty much the same when you think of the development experience, of the developer experience. But I'm going to show you demos. I have these performance tests and load balancing tests. Well, not load balancing as much, because we can see the load balancer, but still we have some of these tests where you can compare consumption and premium. So before we go into my talk, why would you use this serverless? What are the cases where you would use Azure functions if you are building something on a platform as a service? So we aren't talking about virtual machines, we are talking about a solution. You want to implement some kind of application, you have a user, you want her to be happy. She's using a mobile phone, mobile application, and this mobile application, maybe you're in a big company, you have API management there to manage all of your APIs. API management routes the request into an API beneath the API management, published by API management, and this API is probably an app service, meaning that it's just like if you're familiar with IIS, the old time, on Apache, it's a web service, and you've decided what is the size of this web server. This app service is a web server that is running your code and API, and it's always on. So in a situation where you need some more computational power for something that is atomic in a sense, that is logically its own, that the boundaries for this task are clearly defined. So you might think that, hey, let's put that code in an Azure function. Let's say that she wants a report of invoices or orders or her paycheck or something for the last month. Generating this report is something that is very clear, right? It has clear boundaries. So you might think that, hey, I want to isolate this logic inside a clear boundary, a runtime, that would be Azure function. So, and maybe also you don't want to have that computation inside the API that responds to all of the requests from your users. If you have here 1 million users and they send a lot of requests to your server, your API server, it will be loaded, right? So you don't want to have here the high computational need for report generation as well, right? You want to put that somewhere else. So maybe you put that in an Azure function. So then she wants report, she clicks a button, there's a request, give me report, better pencils, give me better pencils, Carl is an Azure function, not dead yet, what's wrong? There's nothing to compute. Oh, I'm sorry if that's better. No, these are all bad. Anywho, so this API sends a command into service bus or some other queue mechanism where there's a message of, generate me this report, and then we have an Azure function, and we have like hundreds or tens of millions of those, and these guys, they are subscribed into this type of message that says generate me a report, and then one of these catches the report generation and starts generating the report, and once it's generated, maybe stores it in a data lake or blob store or somewhere, and then maybe sends a message here that it's done, and maybe this guy is subscribed to listen and it's done, and maybe there's a WebSocket here that updates this screen automatically that your report is done or whatever. So yeah, we maybe got a little past the theme, but still. So Azure Functions is something you might use in that for that purpose. So now we have this new thing, premium plan. You guys speak too much, I gotta drink. So what are its features? It has warm instances, and this is one of the biggest things that's been hoped for. Let's go to the drawing board. So when you think of consumption, what is it really? What is it really? There's a data center, right? Microsoft data center where Microsoft has like millions of servers up. There's a server, and there's a lot of CPU and something there, and then there's this, there's me, and I want something to be done. There's a request coming in, and my application uses this consumption-based Azure function that, starts when it gets the message. So here would be my Azure function. So what happens if the request goes here and this guy is like full? It has noisy neighbors, right? There's like in this Microsoft data center in Amsterdam, there's there's hundreds of thousands of clients, of companies, of applications, of everything running. So the best pen ever. Premium pen. Wow. So there's a lot of noise here, and you are trying to squeeze in your request here, and they can't give you, Microsoft isn't able to give you this Azure function runtime right then. So maybe they can give it to you in 0.5 seconds, or maybe they can give it to you in 0.1 seconds, in 100 milliseconds or something. But if you are waiting for it on your mobile, and the computation, it's lazy code, it's something that's not core feature in the application. Let's say the computation takes 0.4 seconds or something, and then you add 100 milliseconds because Microsoft is throttling you because of noisy neighbors. They're not able to give you the consumption Azure function, because they can't give you, their resources are full at that time. So this is the consumption plan, right? So now in premium plan, you define this host that only has your Azure functions, and what they can do then is that they will have one Azure function running even if there's no need for it. So this is a big change to the consumption plan already, because consumption plan, it's born when there's request, hopefully fast, but not always. If you put 1 million requests in, some of them won't be fast. So don't rely on your Azure functions being like snappy all the time, okay? So in premium plan, you have the host defined, you will see that later, and then you will have one or more, as you define, of Azure functions running already, just waiting for my request. And what it does, of course, this does that it responds snappily. So if you are using in your application, in your scenario, you need these Azure functions that you are using in the sense that you can't allow them to be a bit slower at any point in time, then premium plan is something you need to evaluate. So that is warm instances. And this has been a big ask from the community, from the developers, because sometimes you want to use serverless, but you want to be certain that it responds rapidly. So warm instances. VNet, virtual network, meaning that, okay, let's continue with this picture. So you have this host here defined. This is your server in premium plan. This is your Azure function premium plan. That's what it's called. And then this is your company on-prem. And there you have your favorite application, SAP. And then you need to move data between your SAP ERP and then your Azure function. So in this scenario, it's impossible, because in that sense that you can't, well, it's possible, of course, if you open firewalls and stuff, but if you need to have this consumption-based Azure function in your internal network so that this guy can see your company network, it's not possible. But this host, this can be added to virtual network that is then shared between your company network and Azure cloud. So there we can create these kind of secure network spaces. Unlimited execution duration. In consumption plan, it's 10 minutes. So if you have a code package you upload here, in this scenario, you upload that in Azure Function, and your code package runs in 8 minutes on your beefy developer machine. You put that in your Azure Function, it ain't going to run in 8 minutes. It's going to take a lot more time, and basically that means that it won't work, because here the maximum duration for execution is 10 minutes. In premium plan, it is not capped. So it's unlimited, the execution duration. In private preview right now, and also probably in production when it comes to, when it's generally available, GA, as they say in Azure, when it's GA, meaning that the SLA comes to 4. So that's what you need to wait for if you are building something that you want to have in production and where the business criticality is high enough. You want it to be generally available, so Microsoft provides the SLA, service level agreement, so that it stays up and there's support for it. Anywho, so here it's 30 minutes default, but then it can be, well, infinity is too harsh a promise, but it can be raised to unlimited. Beefier instances. So if you have something on your own laptop, a code that runs in 8 minutes, then you can select your premium plan so that it also is a 4-core or some core with a lot of memory and stuff, so it can be run faster, the thing that you are running. You will see that later with a couple of demos. Then there's high density app allocation, which can be interesting if you work in an environment, if you are working in a corporation or for a corporation or any application where your solution, your application, like this what I drew here, right? This would be one of the simplest applications in the cloud. So if you are creating something serious, you will have a lot of Azure function. You might have like tens of different kinds of stuff. So this high density app application means that once you've created this premium plan, you define this host, then you can have different kind of Azure functions there that are all running inside that plan and all get the benefits that are listed here. So as a demo, here would be the premium plan instance. So for this box, this is a server. I've chosen that this guy is 1-core 3.5 gig machine, and this is my function app that I put there. These are my other 2 function apps that I put there. These are the function instances, right? So this function app, it's running in 6 different instances at the same time, and this guy is in 2, and this guy is in 4, and these are like in some of our applications we've had like 15,000 instances running at the same time. Like if you think of, hey, I have 15,000 files, and you want to like process all of those parallelly, you just shoot 15,000 instances of Azure functions, for example. And this would be the scaling of the plan instance. So you have the server, the turquoise, Azure, what is that color? Whatever. And inside that you have those function apps, and those function apps scale. So there are multiple of those app instances, and then once Microsoft notices, the fabric underneath Azure notices that, hey, this premium plan instance, this host is full now. It can't accommodate any more of these function instances. It doesn't have the resources. It's coming up the cap. The CPU is over 80%. You can put autoscale on it, and then it can scale more of these instances. So your function instances are scaled with more hosts. So you get more power. And once the day is over, maybe your solution is used during daytime. So once the night comes, all of these black boxes here, there are now 4 machines, right? These 3 machines are downscaled, right, automatically in Azure, and then this 1 machine is still left for you to pay for. So you would have, in this case, in this scenario of premium plan, you would have, even at night, if nobody used your application, you would have 1 instance of all of these, your function instance of all of these function apps running, meaning that you would pay for this premium plan host. That would be 100 100 euros a month or something like that. So that is high density app allocation, where you are trying to have only one machine and you allocate multiple function apps inside it. Now the question here is this serverless when you are selecting and you're choosing the host size where you're running, when the utopia, the beautiful dream of serverless is that I as a coder, I develop, I build something out of the abstract thoughts that I have. I'm building this cloud castle, and then when I'm happy with it, I'm just pushing it into cloud and it gets an HTTP address or something, and I can go there with a browser or send an HTTP request to API and it just works. And then I get a bill, of course, how much it's been ran. But in this case, you have to think of the resource size, of the instance size. So that's I'm sad about that. But maybe the benefits outweigh the loss there. But it's not true serverless in the sense of what serverless as a word could mean. But of course, technically, true serverless is kind of hard, sir.
Wouldn't that be rather PaaS than SaaS then, if you're choosing the instance size?
Yeah. In my view, these are if you choose the instance or you don't choose, I would go with PaaS as a word to describe both of them. In my view, like if you think of if you think of the cloud in sense, and let's see, what do you have? You have your own VMs and or you have your own hardware, and then you have VMs, and then you have infrastructure as a service. So you buy VMs from cloud, from Amazon or from Azure or wherever, and then you have containers as a service. So you aren't buying VMs, but you are registering containers and runtime and all of that stuff. And then you have platform as a service, which means that platform as a service means, of course, that you have the code and you deploy that somewhere and it runs. And choosing host or not choosing, I don't think that destroys the PaaS. But the next mode would be FaaS, function as a service, which this serverless is closer. So maybe is this closer to PaaS or FaaS? I don't know if you think of that. But then you have SaaS, and SaaS in my mind is like Salesforce or Dynamics or Office 365 or something where business goes out and buys something and then gets the business benefit out of the solution. But of course, if you think of, well, SAP has been mentioned. If you think of Dynamics or SharePoint or any of those things, you can code on top of that, right? You can extend it. So that is PaaS, because if you deploy your own code on top of a SaaS solution, those pieces are PaaS, and you need to take care of those applications by yourself. So in preview, we have restricted duration for now. We have restricted scaling. It doesn't scale because it's in preview. And it's restricted locations. It's not in every Azure location, but it can be found, these premium plans can be found in North and West EU. Yes?
Yeah, so question about the latency there. So how fast this thing reacts? Like, what is the overhead? So I have my code, I put it there, and I address it somehow. So can you give me some numbers like on latency overhead due to this whole...
I can show you a demo.
Repeat the question.
Oh, repeat the question. So what the question was about the latencies. Yeah. If there's a request, how fast does the Azure function wake up, kind of, and answer?
Yeah, so texture latency between client and the function itself, so due to whatever is in the middle.
Yeah, exactly. You can see that in the demo, but of course, latencies are always difficult in a sense that there's the network, there's the internet, and then there's the load balancing. But because premium plan has that one warmed, it tries to have one instance that is not being used currently, just waiting for the next request. It's a lot speedier than consumption plan. But is there some fixed latency, like fixed ping? No, there's some, of course, some differences how fast it responds. but I will show you a live demo of how fast it responds. So I hope that kind of clarifies that. Sir?
That each instance is served, each request is served by only one instance, or that is reused for between the requests?
So the question was if each request goes only to one function app instance, or if it can be, if a request could be shared, or if multiple requests could come into a single instance. Yeah, no. Cool. So, premium instances, right now there are 3 options. So you choose this 210 total ACU. ACU, that's the Azure Compute Unit, I guess, if I remember correctly. And 100 Azure Compute Units is worth a A1 host, which is a very, very puny host. So that doesn't give you much. You gotta try it out. But it's 3.5 gigs of memory, and it costs you 125 euros a month, estimated. And then there's something that's double, 7 gigs of memory, double the compute, and double the price, and then again double. So that's how, if you look at Azure, that's how virtual machines, that's how app service hosts, that's how all of them go, because one regular rack is like 8 cores, and then there are bigger racks with 16 cores or 64 cores or whatever, but one regular rack is 8 cores. So one core is the smallest, then they can split it to 2 cores, which is double everything, double memory and double everything, and then the full rack is like 8 cores, but this is 1 core, 2 core, 4 core. So basically this here is not necessarily, but could be half of a hardware server that is in Microsoft data center. Why would you go premium? We spoke about this already a bit, but if you need to run functions continuously, so this means that if you need to run functions continuously, like let's say that you have a global application you work for, or in a place where you have some application that is up in all time zones, right? It's in USA, it's in Australia, and it's used in Europe. So you're getting requests all the time. And let's say you have 100 clients, continuously, meaning that those 100 clients, if they are on a web front end or they are on mobile, they click something every 5 seconds or something. So you get 20 requests from them, like every second or something, and you get that all throughout the day. So you will come up, if you calculate how many requests you will get with that, you will come up with millions of requests in a month, like I don't know how many because I haven't calculated my example, which was a great example, but still we are talking like 10 million or more of requests. And at that point, these consumption-based Azure functions will start costing like, over 60 euros, over 80 euros, and so forth, going up. So then you notice that, hey, actually, our application is running everywhere, it's being used 24/7 or 24/5, and these Azure functions are starting to cost something. But these guys are not as beefy as these guys. This guy is like half as powerful. Even the cheapest version, I would say this is like half or more as powerful as this consumption-based Azure function. Meaning that at some point when you pay 100 euros a month for the consumption-based Azure functions, you could buy this with the same money, and you would put half, the same amount more of Azure functions running inside it, because the resources would be enough in that. So at some point, and in general as well, if you look at Azure, and also if you look at other places, Amazon, any cloud provider, pay-as-you-go model, that is something that, of course, is great in the beginning of your solution, because you don't have a lot of usage, right? You will have only a couple of requests. But once you have a large application that is being used by many users all the time, you notice that reserved is cheaper. And that is a fact of cloud life, that consumption-based and pay-as-you-go is good in the beginning, but once your solutions are big, then reserving instances becomes cheaper. Dave?
If you are getting that situation where you have consistent loads,
yeah, Premium is dedicated.
So it's kind of, it's just sort of blurring the line. Like
Yeah.
Are you chasing more power or still cost savings if you're choosing the premium?
You're getting both. At that point, when you notice that your Azure function cost is 125, and you are using regular Azure functions, if you check it today and you pay 125, I guarantee that if you go premium plan, you will notice that your Azure functions are like twice as fast and still cost the same.
It's quite dramatic still.
Yeah, it is. But it only comes at scale. So basically, when you go to need, so if you need to run functions continuously, start development with the consumption based. It doesn't cost anything and so forth. But once you go to production, you can guesstimate the amount of users. Evaluate if you should move into premium plan if you know that you're running functions continuously. Higher performance, we already spoke about that. Longer run duration, we spoke about that. If you are using Azure Function and you need to run them for more than 10 minutes, then the consumption plan isn't even an option to you. Other features like virtual network. Your client or your company requires that it's in the company network, the Azure Function payload, so then you're going to go premium plan. So let's look at the demos.
Can I ask a question?
Sir?
Yeah, about this premium plan, is it also impacting to the scaling up? We have a customer cases where there is a consumer plan,
Yep.
but based on the weather, it can be very burst in couple of hours.
Yeah.
In that case, the scaling up is very slow.
Yeah.
So is this premium plan making quicker?
Scale up. Yeah. So the question was if premium plan scales up faster. So in cloud there are two ways of scaling. There's scale out and scale up. So and scale out means that if there's an Azure function or there's a host, whichever, we just put more of the same size Azure functions or hosts beside it. That's horizontal scaling. That's scaling out. And then the scaling up means that that's usually used with SQL, for example. You have a SQL server in the cloud, and then you notice that, oh my God, our SQL server, it's shit slow. Look, it's in the video now. And then you scale up by putting a beefier machine, more cores, more RAM, and all of that stuff. So I have no answer to you. I don't know. Right now, when they're in public preview, the hardware required by their general availability consumption isn't there. There's a lot of noise made by the Azure Function team saying that Azure Functions run in premium plan should scale very rapidly, just like consumption plan, because consumption plan basically means from Microsoft point of view means that there's hardware. And when there's requests, they actually do scale out and they don't do scale up. So I would, if I was you, I would maybe think of scale outing, because that would be my first guesstimate on how I would start looking at it. But if you really need scale up, I don't know. And on scale out either, I don't know. But they say it's as fast as consumption based. Yeah, between the lines, I think they're trying to claim it's faster than that, but there are no figures. There's nothing. No. And that's, of course, I think that's good in a sense that you aren't noisy neighboring yourself. Because that's something that I haven't liked, because if I have an app service that requires a lot of resources, and then I put Azure functions which can be very spiky and bursty in nature, and they run inside the same host, then they are noisy neighbors with each other. And that's something that this kind of makes clearer. But longer run duration, it's the same in app service as in premium, and virtual network is in app service as it is in premium. So your question is very difficult because you know, I'm embarrassed because I don't know the niggly details where it is really better. But if you read the specs, there's some pointers into how they are trying to say it's better, but they haven't really published anything bigger. All right. About the future, though, once premium plans come GA, I would totally move to premium plan instead of app service, just for these reasons we discussed. All right, so let's like, how much do I have time?
5 minutes.
Really?
Yes.
Shit. This is ruined. Can I have more time?
Yes, you can.
Yes! So I probably won't. All right. So where the hell is this? There. So let's look at the so if you're trying to create a Azure function, is there internet? Oh fuck. If you're trying to create an Azure function and you want it to be a premium function, you just select your function up in the creation and create, and then you give it a name and you create a resource group and so forth. And here in hosting plan you go with up service plan, which has been there, like we spoke of up service plans, and then you create new, and then pricing tier. S1 standard is not a premium plan tier, but here in production you can see these three. These three are premium tiers, premium plans. So take one of those. And if you look at the, I don't want to scale too much out, but if you look at the difference, this is an app service plan, this P1 V2, there's included hardware, there's storage and everything. So this guy, there's some difference in the hardware. You can't change the storage or any of that stuff. Okay, so that was the easy bit. Now I have a couple of functions I've created. I've created one consumption and one premium function, and they are similar in what they do. And there are two functions. There's HTTP trigger 1 in both of these. This is now the consumption view. And this is so these two tabs. This is consumption, Sakari consumption, this is premium. So, and you don't have to care about this. This loader IO is something that we are going to check out, the loader IO, which is this kind of a load performance tester by SendGrid that I've been using to check out the difference between consumption, how fast they respond, really, what's the real difference between premium and consumption. So this loader IO is just a function I need to create in the root that responds with this code, so that loader IO can make sure that this host is owned by me. If you want to replicate this and do something with loader IO or some other you need to verify, then this kind of stuff is easy. But you just have to remember that because there's this in Azure Functions regularly, there's an API URL in the call. Let's say this Sakari Premium website. So here, by default, there should be here between that there should be API. So it should look like that. But the loader IO as a external tool does not check that API folder for their verification text file. So they're checking the root. So I had to go to host.json and change this root prefix. So in Azure Functions, there's a lot of added functionality in host.json you can use to do limitation on run durations and all kinds of limitations on how do you do telemetry, for example. If you send telemetry into application insights in a bundled type or in an aggregate from multiple runs or Azure functions and so forth. So be aware of that stuff. I don't have time to dive in that deeper, but if someone is wanting to test loader IO after this, I can give you examples of that. So the real beef is this HTTP trigger, and I was thinking of showing you through two examples. So the first example is something where this is when you create an Azure function, this is the built-in code. You get the default code. I just added a thread sleep of 5 seconds there. So that basically means that the CPU does nothing, right? It's just sleeping. The thread is sleeping. So I put that there, saving now. This is the premium function. And this is now the consumption function. Let me saving here, so it's 5 seconds both. Now let's try those out. Now this is the premium. I'm calling the premium function. Not yet. Save, run. Did it crash? Why? 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 Script for function worked. Run it here. Yeah, it took 5 seconds. That's fine. Is my URL here? Oh, it's wrong because I added the goddamn API to show you the API. So now I'm running this, and then I'm running another tab. I'm running the consumption, and you can see from the network that these both take 5 seconds something. 5 seconds, 75 milliseconds to do the other stuff, and this guy was less than 5. That's insane. Did I save that? No, I didn't save that. Save and run.
Just write very efficient code.
Is this? Oh, I'm some kind of an unidentified user. That's awesome. No, really, Azure is secure.
That's why it's not working.
Well, apparently we are already breaking some of the services in North and West Europe due to the size.
Ah, shit.
So,
Well, no, it's okay. I ran this last night, and actually I have screenshots of the diagrams, but I would like to show this. It's awesome if Global Azure Bootcamp can break Azure. That actually doesn't sound too good. That doesn't sound too robust. Scott Guthrie will be pissed if this happens. Like, these are the kind of shows where there's a lot of people who haven't used Azure, and as an introduction, if you know, it would be awesome. So that's why it's not answering. So this 1.6 seconds is actually the payload demo I want to show later, because the 5 second thread sleep, I can now maybe wait for this for a while. But so the two demos I want to show is the 5 second thread sleep, because that is the same regardless of the CPU, right? It's going to sleep 5 seconds. So if it's consumption or it's the premium, it's going to take 5 seconds and something, right? And the other demo, I have a payload where I'm looking for the prime that is the 60,000th prime. So there's real work there. So, and I'm running the same payload. So then you can see how fast the premium is as opposed to consumption. And if we load it, what is the result of the timeouts and stuff like that when you compare consumption and premium. So that's what I want to show, but I'm not sure if I'm showing that.
Tulla sellainen babi, se on vaan sekaisin toisella.
Meinaatko?
Meinaa. Normiseen.
Perustabisetti.
No.
Jäpä on niin oikeassa. Mulla oli eilen illallakin vähän ongelmia. Consumption. That's something that probably might happen a bit more today though.
Kyllä ainakin Azure väittää Euroopan olevan ok.
They always do. Okay. Oh, now it's me. Woohoo! Now save. The ordering is not correct, but that's the last one. So let's look at the consumption Azure function. It should take 5 seconds and something. So 5337. Cool. So now we have these two. So now I have this premium AF thing here. And they are the same tests in consumption and premium. I'm going to put them side by side. So that's not correct. That was just testing. So what I'm doing, I'm getting to 100 clients per second during 30 seconds. So, you know, starting from first second, there are some clients and so forth. So this is the demo that I'm running. And I want to run them side by side. So I want this to be, oh my God, let's see what happens. and these to be there. And so on the left we have premium, on the right we have consumption, and then maybe I can zoom a bit. See? And then I'm just gonna run. Let's check that I'm really doing the same test here on consumption side. Yeah, 0 to 100, maintain 30 seconds, that's correct. So run. Close enough. So this is premium and that's consumption. And this was the 5 seconds thread sleep thingy. Premium reached error threshold, it seems, meaning that it reached 10-second average time. Oh, so consumption is doing better now. That's awesome. Didn't happen in my test. Whoa. Let's see another time what happens. I'm running that another time, and both reached the threshold of 5 seconds. I think I ran this without the threshold last time, or maybe not sure. Let's see. Average 5 seconds. So the green bar is client amount. It's growing all the time, as you can see. Clients per second, so request per second. And the average time is the blue one. So now the premium success and the consumption success is a lot better. Premium is executing a lot worse here. This is great findings. I wouldn't buy premium if this was the fact. So let's see what happens when we do the payload thingy. That's interesting. So I'm just gonna, so 60,000 prime. Does it save now? Yes, that is saved. Oh yeah, this guy. Here. Here, prime. So this guy, let's see how long it takes to calculate the prime. So this is the premium that calculates the prime. Wow. Really? Doesn't show the 741, 741 milliseconds, 762 milliseconds, 911 milliseconds. So that's the prime calculation on premium, and on consumption the prime calculation is 1.9 milliseconds, and this is the same code. So this is actually 1.4, 1.8, 1.4. So now we saw that if we look at singular executions, the premium is a lot beefier, a lot faster. But let's see what happens if we get some kind of demo effect when we run the test. So running that test, we just changed the code, so it's the same test. We are running till 100 clients in 30 seconds. Let's see what happens. So now the average time on premium is a bit less than 5 seconds, and consumption reached the error threshold. Premium is still running. Both reached error threshold, which is pretty interesting because I ran this and neither reached the error threshold. That is awesome. But still, running it again. So what we can see here is that when we have a payload that is mostly waiting, right? So there's no CPU stuff going on, then consumption was pretty good. It's not always if you run these kind of tests for a while, you notice that especially with consumption, there might be quite a lot of variance how it goes. Sometimes there's threshold because you couldn't get the requisite amount of Azure functions fast enough, and sometimes there's not. With premium, what I noticed when I've been running this for a while is that the throughput is of course more predictable. So if that's important to you, then that's of course something. If there's a lot of waiting, then premium is not that much better. But if there's payload like finding the prime number, then premium is clearly superior. Let's run consumption if there would be a better copy of consumption plan of getting into 100 clients per second in 30 seconds. So that's a quite a lot of cost, because every second it sends more clients. So it rises into 100 clients per second in 30 seconds. So maybe my requirements are too rough. But if you are looking now, consumption is doing better. This is the same test we ran 10 seconds ago, and it reached the error threshold of either 10 seconds or timeout 50%. Those are my error requirements, right? So, and in the previous run, it was like 5 successful and 6 timeouts or something. So then it stopped the test because too many calls were timeouted. Now we got 2 clean tests of this type of finding the prime, and this premium average is 3.5 seconds, right? There's 321 successful calls in 30 seconds and 1 timeout. 90 kilobytes of bandwidth sent. So here in consumption we see that average is 8.5 seconds. There's 5-second waiting for your client more on this consumption side. There's 69 successful and timeout at 56. That's like almost half of the requests of this payload went through this consumption plan. Of course, this consumption plan Azure function, because in Azure function you choose the size of your memory in Azure function. This is the lowest amount of memory Azure function, so it is the cheapest one. So there's a difference. Send 50 kilobytes. So you can see that the performance on this premium side is a lot better. But you gotta remember, this cost me a cent. This is costing me $125 a month. So if you look at the price multiplier, it's like hundreds of times. If you let this run, it's 125, and this is not. This is a lot less. Okay. I think hoping I gave you some ideas and some other stuff on serverless as well. Any questions before we go forward? Awesome. Thank you, guys. I don't know what's next. Is it Timo? Timo!